Hi everybody, I'm Pete Cook and this is the Hydrogen to Human series, a short series of videos that explains how nothing more than clouds of hydrogen self-assemble into human beings. In part one of the series we looked at the big problems in science, and the main problem was how we go from simple to more complex in the structure of the universe. And we looked at entropy. Now, the energy always becomes more disordered. So the reality that I observe, which is very, very ordered and structured, seems to contradict that. So there must be something missing from our science. Brian Cox has put it like this: there must be a bank of order here that can become more disordered. Doesn't seem to make sense, because back here I've got a cork gluon soup. So here's the answer. If I just try and explain reality using the physics, the energy, I can't. I go straight into trouble. But if I describe reality using other aspects of this energy, which are not the physics, I get an answer which is logical. Now, it was Benjamin Franklin who first started to use this, but we've been using it ever since. We use it so much, we just got used to it. These are the aspects of electrical charge from the physics which we must use to distinguish the electrical charge on the electron and the proton. That's 1.6 times 10 to the minus 19 of a coulomb. And they're both exactly the same unless I say one's positive and one's negative. Well, what does positive and negative mean in terms of physics? It doesn't mean anything. It's a mathematical aspect. And it just means that relative to this, this one behaves differently. Relative to this one behaves differently. And they are symmetrical. Again, that's an aspect of mathematics. So if I use mathematics, pure mathematics, and physics, I now get an answer. I can say that here my cork gluon soup, beautifully uniform, ordered energy with completely disordered structure. I'm going to build the structure using the qualities that come from mathematics. The quantities of the energy don't make them fall together, don't have any forces. It's the qualities of the mathematics which cause the forces. And I've got to have something different about them. If I've just got energy and I've got two units of energy which is the same, I don't get the force, the electromagnetic force. So the qualities, how it behaves, the forces that cause the structure to build up are coming from the mathematics. The mathematics can become more ordered, the energy can become more disordered. I don't end up in contradiction. Now, it's very important to understand how this has worked. This is governed by the second law of thermodynamics. So I must be able to show what I've just said in that second law. So let's read what it says in my book, Quantum Aspects of Life. Now, this was written by some very, very smart chaps who realised that the universe is a computational place. It's a big computer. Finally, over decades of painstaking analysis, Maxwell, Boltzmann and Gibbs discovered the mathematical formulation for entropy in terms of the motion of atoms and molecules. Phrased in contemporary terms, their formulae stated that entropy was proportional to the number of bits of information. Every time two atoms collide, those bits are flipped and processed. The way in which bits flip when two atoms collide is governed by the Boltzmann equation. The discovery that at the bottom the universe computes was made more than 100 years ago. So we've got the universe changing energy into information and structure. Now, information just means I've got zeros and ones. I've got nothing. And every time I make something, I change the quark gluon soup into protons. I've got a new 1, a 0 and a 1. I'm getting more structure here. I need 3 quarks to build a proton, and those quarks must have qualities. Qualities which can be mathematical, positive and negative. I need up and down quarks. I've got other aspects which are different. I need the colour forces to build atomic nuclei. So I'm seeing that I'm going to make protons, a new 1 of something. And I can then build neutrons, a new 1 of something. And then I can build atoms, a new 1 of something. So I'm matching up what happens in mathematics with what happens in physics. And that's already been seen by people like Max Tegmark in his book, The Mathematical Universe. Let's see what he says about mathematics and physics. The mathematical universe hypothesis implies that mathematical existence, something new that exists that didn't exist before, equals physical existence. This means that all structures that exist mathematically exist physically as well. Now that's a big statement, but let's see how it works. And it's the qualities, the differences, which cause the forces which cause change. Now here is the definition of mathematics. Mathematics is defined as quantities, form, space, and change. Quantities, quantum mechanics, entities which have mass relative to space. They distort space. Space is distorted by mass, mass is distorted by space. I get new quantities, gravitational quantities, stars, and elements building themselves at the same time. The relationship between what's happening at the quantum level, what's happening at the gravitational level, building more structure all the time. I get change. I get time. Now I'm going to show you in later programs how we can express all that mathematically. But arithmetic, the quantities, the numbers, the geometry, how those quantities relate to each other, the shapes and the form, how everything relates to each other, the relationships, quantum mechanics and relationships and relativity equals time, change. I'm going to put all that into one equation later. But let's have a look how that shows up in mathematics. We're already used to the Argand diagram, the relationship between imaginary numbers, which don't have units, which are used for counting with, space, and the quantifiable parts of energy, quantum mechanics, the units, which relative to space have mass, which distort space, and space distorts the mass. That's general relativity, the relationship between mass and space. That's what gravity and mass are. Mass, the individual level, gravity, the collective level. I get these conjugate pairs. That's what general relativity is. I'm going to use the same principle again to show you the other fundamental forces also come in these conjugate pairs. This distorts this, and this distorts this. This changes this, this changes this. So I've got my real and imaginary parts of mathematics and physics. I get fields in space caused by the presence of the real parts. And I get distortion in space caused by the presence of matter, distortions in matter caused by the presence of space. I get a pair, real and imaginary numbers. But I've also got positive and negative numbers. I get electromagnetic pairs. So I've got a pair here, the gravitational force, a pair here, the electromagnetic force, and then there's only the strong and weak nuclear forces. I get odd and even numbers, and I get all of those aspects in my Argand diagram, but I need to add another pair of numbers, and I can put them all together. So here, now, I've got a completely different picture of numbers and physics. I've got my positive and negative aspects of imaginary numbers. I've got my odd and even aspects. And I've got my real and imaginary numbers. Now, real and imaginary numbers change each other. Those of you who understand that in mathematics will already see what's happening. So I've got strong and weak aspects, positive and negative aspects, real and imaginary aspects. I've got strong and weak parts of space. General relativity does not just apply to gravitational fields. It also applies to magnetic fields which are strong. The magnetic field of the Earth is a very strong distortion of space outside. But this also works down at the atomic level. Because it's strong, it works on individual components. So I've got distortions of space which work at the individual level for the small, the atomic parts. Distortion of space which work at the gravitational level. It only works at collectives, it's so weak. And they act against each other to build stars and elements. And I need both. The magnetic field determines that the particle, or the entity, the unit of energy, is a magnet. It determines its behavior. So I've got strong space, weak space. I've got strong units of energy that we call matter. I've got weak units of energy, the photons that we call radiation. And everything has these dual answers. And now I've also got the strong and weak nuclear force, the direct relationship between fermions and bosons, and they change the behavior of each other. They cause forces, they cause things to happen, and there is a mathematical relationship between the fermions and bosons called the Mobius function. And they behave in exactly the same way. That mathematical function needs Pauli's exclusion principle, so I can't square numbers, I'm not allowed to. And that gives me three pairs of relationships in mathematics and physics. And what happens at the gravitational level acts against what happens at the atomic level to build stars and planets. The star is made from the gravity acting against the energy released from atomic nuclei. Atomic nuclei need this pair of forces acting against each other, the relationship again, to release that energy and hold that star up. If I don't have a relationship between the atomic level and the gravitational level, I don't get the star, it collapses straight away into a black hole. And I can put that in a little diagram here that shows it's exactly the same at the planetary level. The planets, I need the repulsion of the electromagnetic entities acting against the distortion in space which is causing them to fall together, the gravity, to hold that planet up. So it's a relationship between gravity, space and matter, acting against the strong and weak nuclear force, the electromagnetic force that builds stars, a relationship between space and matter, and the electromagnetic forces that build planets, and a relationship between these two forces that build elements and objects, something that's too small to be formed by the gravitational part. It both attracts and repels, it holds itself up and holds itself apart. So that is a completely new description of mathematics and physics, which is logical. Now in later programs we're going to go on from the static, the simplicities of the stars and the elements building themselves, and we're going to go into molecules, solar systems and life. So this takes a little while for you to process, but there's no way out of it. Everything I've just said is exactly the same as the reality that we observe, and there are no contradictions or problems with it. See you in part 3. Bye bye now.